Hey everyone, in previous lecture I discussed how can convert ER diagram into relational schema or table. In today's lecture I will discuss binary versus n-ary relationship and generalization specialization. This is the last part of ER diagram. If one relationship set is related with just two entity set, it's called as binary relationship. Suppose this is a relationship set and it is related with two entity set. It's a binary relationship. In the same way, if a relationship set is related with multiple entity set, then that's called as n-ary relationship. If entity set number is greater than 2, then it's called as n-ary relationship. We can easily convert n-ary relationship into binary relationship, as binary relationship is easy for doing ER diagram and for finding the relational schema. Let's see one example. Here we have a ternary relationship. There are three entity set. How can convert that ternary relationship into binary relationship? You can see R is related with A, B, C. A, B, C are the entity set. R is the relationship. We can add another entity set, let E. So A can related with E, B can related with E, C can related with E. So now RA, RB, RC all are binary relationship. Here this R is split into three relationship, RA, RB and RC. Next, extended ER features. Here basically I will discuss generalization and specialization. Specialization means we specify some group. Like person, we can divide as teacher and student. So every person is either teacher or student. We are subgrouping within an entity set. That's called as specialization. So this specialization of person allow us to distinguish among according to their corresponding employee or student. We can also say superclass, subclass. The parent class or higher entity set is called as superclass and the lower entity set we can call as subclass. Opposite of specialization is generalization. Generalization is a containment relationship that exists between a high level entity set and one or more lower level entity set. When we generalize, when we find the union of some entity set, that's the generalization. The design process may call as top down or bottom up manner. Top down means from parent to we are going to child, and bottom up means from child we are going to parent. Or you can say from higher level to lower level is called as top down, from lower level to higher level is called as bottom up. Higher and lower level also you can say super and subclass respectively, and the attribute of higher level entity is inherited by the lower level entity. Or you can say the attribute of superclass is inherited by the subclass. Total generalization, each high level entity must belongs to lower level entity. That's called as total generalization. If some high level entity belongs to lower level entity, that called as partial generalization. So specialization and generalization, these are the relationship between higher level and lower level entity set. Specialization is result of taking subset of higher level entity to form lower level entity, whereas generalization is the result of taking union. Okay. In case of specialization, we are taking subset. In case of generalization, we are taking union of two or more disjoint, or we can say lower level entity set to produce the higher level entity set. So specialization, we are going higher level to lower level. In case of generalization, lower level to higher level. Next, aggregation. Aggregation is an abstraction in which relationship set treated as a entity set. Okay. So one relationship set along with their entity set are treated as higher entity set and can be participate in a relationship. That's called as aggregation. That's it for today's lecture. In today's lecture I discussed extended ER feature, that is generalization and specialization. In next lecture I will revise all the ER diagram notation, and that will be last part of the ER diagram. If this lecture is helpful for you, please like, share and subscribe. Thank you. Bye bye.